So I'm calling it Make Your Thesaurus Smart. So the brief outline is, what is linked data and why do I care? Dan will come up for part 2 and talk about how to establish those links, and then I want to talk about the cool stuff you can do. Because I know it's after lunch and it's Wednesday afternoon, here's my outline of part 1. Outline, what is linked data? Why do I care? Just seeing if you're all paying attention. So lots of people talk about linked data. We heard Rebecca Shibata talk about linked data. We heard Kevin Ford from MarkLogic talk about linked data. We could talk about representing our various taxonomies and ontologies as triples. We can talk about how those things fit into a stack. We can certainly talk about the web of linked data sets that all tie back to some central data set and how those all interact and how we all want to join that and become part of the big web of information. And we can draw more things about all the fields and triples, and we can talk about SCOTs, and we can talk about OWL, and I don't want to talk about any of this stuff right now. I want to talk about what it means for a thesaurus, why you want to put it in your vocabulary, and what are the applications of that. So I'm not going to get down in the technical weeds. If you want to get in the weeds about it, come talk to me later and we'll get in the weeds about it. So for our purposes, what is linked data? And what do I mean by a smart thesaurus? So Wikipedia has a bunch of data in every page. There's something like 4 Brazilian Wikipedia pages or something. Each of them has a bunch of data in it. Some of that data is structured and some of that data is unstructured. If you look at a typical Wikipedia page, sometimes there's an information box on the side, and you'll see those things when you search Google. It'll pop up a box. It looks like they took it right from Wikipedia. Why is that? It's because that information from Wikipedia lives in DBpedia, and you'll also find the references and any photos referenced and linked to a topic. So parts of the DBpedia, which is not as robust as Wikipedia, take the data right from Wikipedia. So the title of the page, wikipedia.com/optics, is the data that's represented in DBpedia is represented by the page dbpedia.org/page/optics or something very much like that. Plus, people can add data to DBpedia. If you look at, I wish this was a little clearer to read on this page on optics, which was a topic I picked. These external links, there's a link here to SPIE, and there's a link, there's a link to OSA, and there's a link to a page from BYU about optics, and there's a link to IOP, not AIP, I noticed, but a bunch of external links to DBpedia, and then there's people who work in the field, subtopics, journals that publish on this field. All that data is contained in DBpedia. So besides just what's in Wikipedia, here we go, there's the slide I thought I had, there's an abstract. Sometimes it's the first paragraph in the Wikipedia, sometimes it's something else someone has edited. Images in Wikimedia Commons at this URI are a bunch of images about optics. Here are external links about optics, subtopics, and foreign language links, and etc. And there are lots of sources for topical information. So here's the AIP page on optics, and here's the PLOS One page on optics, and here's the Optical Society page, homepage. Here's the SPIE homepage. All these things are about optics. And all of them, or almost all of them, have links back to the DBpedia page. So they're all about the same concept. How do we assert out in the world that the Optical Society publishes on the same topics as SPIE and this page in PLOS One and this page in AIP? Well, the sort of old way of thinking is that we would try and assert links between each of these pages to draw the reader from place to place. But then, the more things that proliferate, you have to keep track of these links. If someone moves their web page, you have to keep track of the new URL. So we don't do this anymore. What we're going to do is find a persistent URI, and that persistent bit is key, and I say that a lot, and I feel like it just goes one in ear and out the other sometimes, that everyone can point to. So that if you change the URI on your page, you don't have to change the external reference to all the other people that publish on your topic. You just have to reassert that it's back to this one DBpedia page and make sure you go edit the DBpedia page to reflect the URI that you're on. So what we're establishing is that this is just a page. This is just an information clearinghouse on DBpedia, but anyone can add a link to their topic that's about the same topic to it, and you can add a link from your topic back to it. So what does it have to do with my thesaurus? Oh, sorry, jumped ahead. But wait, not all those sources are listed on the DBpedia page. You noticed this because you were paying attention. The AIP page isn't linked yet, and I assume Citation wants to link out there, but it's not there yet. Why is it not there? Is because you haven't asserted a link to your data. But it's starting to sound like we should. So here's how it relates to your thesaurus. My idea is that we take every term in a thesaurus. Here is, I think this is the DHUG thesaurus that I use for this. They have a topic of optics with a bunch of subtopics that's in their hierarchy about all kinds of science. And we're going to add to a field to the thesaurus, which is very easy to do, with an external link, and then we're just going to assert a link from that topic to the DBpedia page with the same topic. Once you've asserted this link, then you're also, by extension, asserting that you have a link that the DHUG content on optics is the same topic of optics that it is on AIP and on PLOS and on SPIE and on OSA and all Encyclopedia Britannica and Wikimedia Commons Images, that all these things are about the same thing. You will also, go ahead.
One link per term?
That's my idea.
Just checking.
We're going to run into some granularity issues that we'll have to address.
Okay.
You will also want to make sure, and you go back and add a link from your thesaurus back to the DBpedia page to participate in the community of linked data. That is so other people can get to your content from DBpedia. So this all sounds like a great idea. We're going to make our thesaurus smart by adding persistent URIs to a topical page that we assert is the same topic as the topic in our thesaurus. How are we going to do this? So I'm going to let Dan talk about it.
You have this.
Oh, yes, indeed I do.
So Mary can hear us. Okay. So I'm going to speak about sort of the underlying structure that Bob is referring to. And you've all seen the Wikipedia and know something about it. And I'm going to repeat a lot of that stuff that you already know just to, so that it's at the forefront of in the front of your head. Anyway, and then I'll, as Bob points out, I'll go over the DBpedia and how we're relating these. And then I'll mention something called the Spotlight, which is sort of based on the DBpedia. And we'll go from there. I thought I just talked about that.
Page down.
Yeah.
No, just use the down arrow.
Oh, the down arrow?
Yeah,
Okay.
that's the one.
All right. Well, first of all, we really could put just about everything we know, all of human knowledge, into the Wikipedia. That's sort of it seems like people are doing right now. That, we don't even have an idea about how much knowledge that is. I mean, there's a lot of stuff out there that we don't even know we need to know yet. Well, there's already a great deal of information in there, and we can look at that. And I've got some graphs showing how it's been growing. I'll compare the Wikipedia to Encyclopedia. And as Bob pointed out, the Wikipedia already contains links between Wikipedia pages and external links. So each one of those is really a link that we would like to be able to follow, as Bob pointed out. And if we had a standardized way of doing that, which Bob was suggesting, we could do this automatically. And so the whole idea is to build on the structure that's already there to produce sort of a database of all human knowledge, so that we would enable anyone in the world to be able to know essentially anything they needed to know. This would be a great idea, I think. I mean, everyone agree with that kind of an idea? So here's sort of a rough idea of what's in the Wikipedia and how it compares to what we used to use as well, I still got an encyclopedia. We probably have a few encyclopedias stashed away in our storage room somewhere. But you can see that the Wikipedia has about 20 times as many authors, 100 times more articles, 1,000 times more pages. I mean, it's huge. yet, so if you printed up the Wikipedia on encyclopedia size, Britannica-sized volumes, about an inch thick or an inch and a half thick, and each one of these little blue bars was a encyclopedia volume, and this was a human being. It'd take 11 stacks of them. There'd be 10 that'd be completely full, and there'd be 87 volumes left on the partially empty bookcase. That looks like a lot of data, right? However, the size of the Wikipedia, if we put it on a DVD, or we'd have to have 6 DVDs, because it's roughly 25 gigabytes, and you can count them, there's 6 DVDs. It starts to look a lot smaller. It'll easily fit on one Blu-ray disc, 25 gigabytes. This is actually a 200 gigabyte version of the Blu-ray disc, so you could actually fit about 8 or 9 of them on there. And here's a little, this one's actually about the size of a postage stamp, an SDXC card that holds 64 gigabytes. So it holds 3 copies, almost, of the Wikipedia on that little piece of SD card. So that makes the Wikipedia look tiny right now. And here's how it's been growing. It looks like it might be tapering off, but if you think about human knowledge, I mean, there's 6 billion people in this world, and each person has a certain amount of knowledge. If you thought about encoding that, it would be a lot more. You wouldn't expect it to be tapering off like that. Who knows what's going to happen? I mean, this is predicting the future is kind of, it's hard. So here's an example of Wikipedia page, and as Bob was pointing out, sometimes they have a little section over here that gives you broader and narrower terms. In this case, it tells you which phylum the bear is, okay? It's animal, it's in phylum Chordata, and things like that. And then there's lots of other links inserted in the page. And we can actually we can capture all those links, but we don't have a standardized pattern for doing that, because the people, this is written, it's crowdsourced. I mean, anyone in this room could go out there and modify this page. And in fact, I've done it. I used to maintain several of these pages. So, but there is a pretty standardized structure in the Wikipedia, and as Bob was pointing out, this part here could be called an abstract. If we grab that, we could automatically grab that piece of information, call it an abstract, give it some XML tags, and put it in the DBpedia, essentially. And that's what happens. That's how the DBpedia is built. And we can grab these standardized things when they're there, and we can make them into SCOS. Well, a university in Germany about 5 years ago decided, well, this is a good idea. We'll build on this idea, and we'll make the DBpedia, and that's how the DBpedia was born. The original concept was that it would be crowdsourced, and it still is. That's why Bob was, as he was pointing out, any one of us can put information into these DBpedia pages. Now the next part is that they designed a query language that looks a lot like SQL to work against these DBpedia pages. And if the structure turns out to be useful, some people, the people that maintain the Wikipedia and the DBpedia might be inspired to actually cooperate and do some things in a standard way so that information can be automatically put into and pulled out of. We can actually automate the queries. We can count on a structure. So and there's problems, of course, still. Here's the DBpedia page for bear. I showed the Wikipedia page, and here is indeed the abstract. That's the way it's built, okay? And class, kingdom, order, mammal. You know, we've got, that's how the data was extracted, and it was successful in this particular case. Oh yeah, it did that, okay. So now there's another motion to automate this. You know, I mentioned that it would be good to automate it. Well, there's a software program called Spotlight that you can download. You can install it on your computer. It costs nothing. Only thing is, it takes you a little bit of resources. It's an entity linking tool, and it takes free text and inline tags that text to show you where it discovered concepts that are in the DBpedia. Concepts and entities, things like that. Automatically, but as all of you know, I'm sure. Well, no, this you didn't know. Spotlight uses context for disambiguation, so that it actually has some sense of what the context is. There's rules out there, essentially. And it runs as a service on a network. So you put it up on one of the computers on your network and send out queries to it. And of course, if you do, you know, there's economical things that you need to worry about, but if you submit a large number of little jobs and each one of them takes a second to go across the network, and you do 1,000,000 of them, it starts adding up. So you don't want to do things quite that way usually. Just initiating the server takes about 4 minutes of elapsed time. So it's something to consider. You know, you don't want to start her off all the time and start her off again every time you want it. But the way I run it is I start it and I just leave it there for however long anyone wants it. A minor, well, major actually, it depends on how you think of 13 gigabytes of RAM storage. 13 gigabytes, we have several computers that size here at Access Innovations. But it takes a lot of storage. And it runs moderately fast. It'll write or process small files at about 50 files a second. So I took some random text and indexed it, 4,800 articles, and produced terms using the Spotlight function. And this is a graph of the number of terms per article. The average was 14.7 or 13.7, right where these brown dots are. And if you plot that on log scale, you can see it's a straight line. So it's very likely an exponential distribution. So that you really do have a feeling for the distribution of the number of terms that come out of any article. It's probably just a density. There's so many terms per article. In this case, 14.7, 13.7. Oh, and
Is that me then, or is it?
what?
Is it still you?
Yeah, 2. Are you anxious? Where was I?
On 2.
Yeah, on 2.
You guys rehearsed that.
There. Well, I was going to say a few words about the kind of terms and the curation of the Spotlight results. That is, people, it's crowdsourced, DBpedia and Wikipedia, so there's not a consistency in the way things are processed. So you don't always get back, like if you type in bears, you'll get, from Spotlight will produce something like the Chicago Bears. Unless, you know, there happens to be a lot of animal references around there. Similarly, if you type in, if you see something like Yankees, it will be New York Yankees and not the Northern Army against the rebel forces in the Civil War. So, you know, but indeed, you get, there's some consistency in there, and you get back results that look a lot like that. You know, there's some good ones and some bad ones, so you need a little curation to go on there.
Yeah, I was just going to ask you, if you get a bad match, how do you get rid of it? I mean, how do you edit out the term, or how do you edit out the concept so that it's either not making that mistake going forward? I mean, if you're trying to automate this,
Right.
you have to be able to do something, but then at an early stage, you're going to have to do a certain amount. Somebody's got to review these things and see if you're getting Chicago Bears when you mean grizzly bears, and you know,
Exactly.
so forth.
That's one of the problems with freebie software.
Okay.
It's crowdsourced. It's developing. It's improving.
But is there a way to edit whatever your result is?
As much as you provide, of course. And
Okay.
here, I'll tell you some of the things that we have to work with.
Okay.
The terms that it automatically matches the words in the text in your document against the Wikipedia terms, or actually DBpedia terms, and it gives you a measure of what the match is. Like if it says Bears and it matches with Chicago Bears, it decreases that match. So you can edit and say, oh, I'm only going to take 100% matches or something like that. And that allows you to control the quality in some sense. It still doesn't solve the problem, because if it just says Chicago Bears and you really meant grizzly bears, that requires either a much more intelligent weighting scheme, or else human intervention.
Yeah,
and you
but
don't have time.
I guess what I'm saying is, even with Maestro, I mean, you can just automatically tag your content and not review the terms.
Right.
But you'd be an idiot to do that.
Exactly.
So you have an opportunity to review the terms and then accept the ones that you want or not.
Sure.
And what I guess I'm trying to get at here is there a mechanism in there to accept or not accept whatever the kinds of results you're getting back?
Well, right now there isn't anything. We could
Yeah.
dump them to a spreadsheet, dump them right into your Thesaurus, dump them to your email, dump them to a text file, and
Yeah.
it can be whatever we want.
Yeah.
The point is, well, I stand up, that
Yeah.
somewhere between looking up every single term and trying to type in a link,
Yeah.
and automating all of them and never reviewing them, is a place where we automate as many as we can and QC them to find the ones that
Okay.
matched. So what that mechanism is, we have yet to design.
Okay.
I imagine
All right.
at this point, I would dump them into a spreadsheet or something and have a list of terms and a list of possible links and
And
browse
just
them.
run down the list. Okay.
Till we establish a mechanism where we can use
Sure.
the weighting slider or something where we're confident of X number of them, we only QC the ones we're not sure about. And then it's gonna be a question of the ones we weren't able to match automatically.
All right. Thanks.
Now, most likely what we would do is take the weights that come out of the Spotlight function and have some scheme for separating the terms that come out into ones that are highly confident, questionable, and rejected. And then we look at the ones that are, well, let's look at those, because they may be interesting. And then, as Bob points out, we don't know exactly. We've got lots of possibilities here, and it's just a developing idea. So, as I mentioned to Charlotte earlier, you could search a body of content for candidate terms. And then, if we do this a few times, we get some feeling for how it goes. And the better, you know, we may discover something. I think it's just a question of looking myself. I studied matching Thesaurus terms. I think this is Bob here, right? Is this you or is this me? Me. Okay.
Oh, this is your last slide, I think.
Yeah. This was matching, in this case, optics. I don't remember why I had that there. Oh, okay. This is, I think
I made him this slide. So the idea is that instead of running a batch of content, or why not come around?
yeah, I think it's your turn.
So one of the problems here, and this is wrapping up Dan's section, is that DBpedia Spotlight uses, much like MAI does, uses context to parse whether you mean grizzly bears or Chicago bears. What we're trying to do currently is run one thesaurus term at a time through it, so that when you see optics, you get optics, you add optics to your thesaurus, and then everyone's happy. Now we need to say, should we run entire branches at the same time? We need to develop a strategy to add context to these terms so that DBpedia has a better chance of getting a good match. Because the very first time we tried this, the reason we keep bringing up the bears and the Chicago bears and the grizzly bears is we literally got Chicago bears as a match for the term bears in a thesaurus. And we were trying to figure out why that was. It turned out that it was a singular plural problem more than anything else. So the first use case, after we do a little strategizing about how best to do this, is to automatically take every term in the thesaurus, see if we can find a match, auto add a link to the tag in your thesaurus. And then the second use case, which is something Charlotte and I were actually talking about yesterday, is, okay, I have a thesaurus, and I have a thesaurus review process, I have someone who maintains my thesaurus. How do I mine for new concepts in the thesaurus? Well, you can take your massive pile of content and run it through Spotlight, and have it look for terms that are in DBpedia, and then send those terms to your taxonomist to see, it's Linnaeus, of course, to see if those terms are warranted to add to your taxonomy, if they have warranted in your content or some kind of user warrant. But it's a way to mine your content for relevant terms that you know there are good external resources for that you might want to add to your taxonomy.
Okay.
Oh, and then your taxonomist adds them to the thesaurus. So, go ahead. Oh, thanks. Given that we still have some problems to solve, but that the concept is sound, let's say we got this executed. In our initial tests, we were getting 40 to 60% automatic matches from DBpedia, and most of the things that didn't match were too granular. There's a DBpedia page for optics, and there's a DBpedia page for nonlinear optics. There's not a DBpedia page for photonic metamaterials, or most of the topics underneath nonlinear optics. It just doesn't go that granular. So the question becomes, do you not produce a link for those? Do you create a new DBpedia page for all your terms and become the envelope pushers, adding to the big linked data community web of knowledge of the whole world? I think these are questions each organization would have to answer for themselves. But if the idea is sound, and we can add external links asserting to a persistent URI, as I keep saying, for our taxonomy terms, what are the cool things that we could do? We could add information to our thesaurus. You could put a definition field in your thesaurus or an abstract field and query off all those abstracts and slap them in a field. You can, I'm going to go through these each a little more. You could add enriched inline tags. You can link out to other data sources, or you could populate your page with external content. So we have an external link, and we have a page for that link. We could take the abstract, make a button in our thesaurus, add for definition or abstract, and just query all those out and add them to our thesaurus. That way, when you go to your research website and we have inline tagged terms, by inline tagged, as it was explained at some point, we mean that you put a little XML wrapper around the concept every time it happens in your content, and then you can do lots of things with it. You can highlight it, you can underline it, you can query Google on that term, or you could add a definition from your thesaurus that you've already queried out to that term, and when you mouse over it, it pops up the abstract from DBpedia. It could also be used to launch a search, either in your content or a general web search. You could redirect the user to your topic page. We just had a conversation about topic pages on that content in case they want to search further on it. You could launch a Wikimedia Commons or other Google image search on that term, since we already know it's a well-established quantified term. Or use any other information that's on the DBpedia page. You could have it, I don't know why you'd want to do this, pop up a list of other journals besides yours that publish on this topic. Or Charles shaking her head. Or prominent people in the field, or any of that other information. Some of these DBpedia pages are scrolls and scrolls and scrolls and scrolls deep about the relationships that they've established, all in triples. So it's all machine readable. You can query it all off and know what you're getting and deliver it to someone on a mouse over term. You can also link to external data sources so that if you have, and again I keep using optics because it's a great example, you could pop up a sidebar on your website that says, hey, you interested in optics? Here's all our content. You might also be interested in all these other associations or places or organizations or universities with departments that publish on optics. You could also offer, and this is the strategy that in linked data circles, the BBC Wildlife has famously pursued, where they offer their content on a page. They atomized all their content. So the story is, for anyone who doesn't know, the BBC Wildlife had their funding just brutally slashed. This is 5 or 7 years ago. And they had all these initiatives that they wanted to do on the web. So they decided they were going to spend their time and money for their editors to curate links instead of curating content. So they don't make web pages, they make links. And then the web pages are created dynamically on the fly. So if you look up wombats, or optics, in this case, you get your content atomized. Here are all my articles about optics, here's all my stuff about optics as far as you can go. And then in the same portal, you can offer content from other places that you query off because they're all linked to DBpedia. That could be images, other journals, Google Scholar results, a Twitter feed, a Google News feed, anything that you can think of that you can query off the web because you've already asserted this persistent link. You can add and make your website the portal to go to, so everyone knows, even if they're not going to find it on your website, they know they're going to come to your website to look for information on civil engineering or physics or whatever it is, and they know they're going to get redirected to a good resource that's somewhere else.
And
So
you've got this built into Search Harmony, right?
it could be built into Search Harmony. There's certainly no reason it couldn't. In fact, there's plenty of white space on that page that we could put all kinds of stuff in. I also like my banner, by the way, your awesome research website. And then finally, really, and idealistically, we have this sort of big bubble graphs of the web of knowledge that you keep seeing. Every time someone starts a linked data talk, right, this is the first thing they show to you. What you really want is to get your stuff into that web. So that when somebody goes to DBpedia or GeoNames or Music Brains or wherever US Census data and they find their way back to DBpedia, there's a link asserted to whatever the specialty that you publish on or you curate, that topic is linked into this web. It's time to get all of our stuff in the web. If they hit a paywall or a member wall when they get to your site, that's fine. At least they know your site is there. It doesn't mean you have to offer all your stuff for free. It just means you've got to put the hooks in there to get the stuff from your, to get from your content into the web of linked data and into the web of knowledge. So that's my final plug for the idealistic vision, but that's basically my idea. Questions?
Well, Bob,
Dr.
in
Bainey?
terms of problems like you have a 7,000 term thesaurus or 17,000 term thesaurus, and it's easy enough to go out to DBpedia and make a link. You can find such a link to one of your terms, and then you raise the problem of curation and how valid is that? Bears, Chicago Bears, Grizzly Bears, and other sports teams with bears on it. could you not surface all the DBpedia pages, pull the abstracts, and run the MAI?
Oh.
Disambiguate?
That's a good idea. That's a good
If you have a
idea.
rule base based on your thesaurus, then you just run the MAI and you reduce a fair amount of the noise. It's still not 100%. Just like MAI is not 100%.
No, but as
We
a,
strive for 85%.
as a QC loop, because what DBpedia is, what Spotlight is craving, as we talked about, is some context. When you run a single taxonomy term, you're not getting any context. So Dr. Van Emen's idea, I would scribble on the board if I could, is to then loop back, pull the abstract once you make that link, run it through MII and see if you still get the same result as a way of cutting down on the amount of human QC you have
Right.
to do. Oh, thanks.
We can do it.
Oh, if I'm given another opportunity to do, I will. And the other question I think that falls out of that is, I have, 3,000 terms on optics and 6 of them were in DBpedia. What do I do with the rest of my stuff? You could roll it up and say anything under this branch we're going to call that same link, so at least you'll get some content fed in. Ideally, the solution would be you're going to go create DBpedia pages for all your specific content. Every academic publisher goes and adds more granular stuff to DBpedia. It'll eventually get more and more granular and more useful to more and more researchers. That's a little bit idealistic.